You're welcome to my YouTube channel. Presenting this lesson, I'm Tutor Patrick Divine. So in this video, we are going to do chemical formulas, and we are still doing chemical formula. We actually did in part 1, 2, and 3. And lastly, today we are going to finish up with part 4 of the chemical formula. So if you didn't watch these other videos, kindly go back so that we can move together. The videos, they are always there on YouTube. You can search for my name, Patrick Divine, and they will come. You watch the videos that we actually did in the previous. Okay, so if you are new to this YouTube channel, kindly subscribe to the channel. So how you're going to subscribe is when you are watching this video, down there is like, there is share, there is subscribe. So you go to where there is subscribe, and when you subscribe, that means that whenever I do a video or a lesson, should I say, you'll be able to be notified. So in this video, I'm going to solve the assignment that I gave you in the writing chemical formulas part 3. I gave you the assignment, and I received quite a number of people trying to solve. Others got everything, others tried their best, and I want us to solve it together. So this is the assignment that we are given. If you remember, this is the assignment that we are given. So we are saying that write the chemical formula of the following. Okay, so here we have these elements. There is sodium sulfate, there is beryllium oxide, iron 3 carbonate, calcium hydrogen carbonate. Okay, so these are the chemical formulas that we are going to make sure you understand, and so that we can move together. So if you are new to this YouTube channel, I'm Tutor Patrick Divine. That's my name. Yeah, you may follow me on Facebook, on WhatsApp, on Twitter, the same name. Okay, so you'll be able to watch these videos. They are there. You'll be able to watch them. If you need tuitions, online tuitions, you can WhatsApp me on this same line. This is my number, +260 975 334778. If you need online tuitions with me, I'm available. Okay, all right, so we are going to do the assignment for chemical formula, and the first question that were given was saying that we should write the chemical formula for sodium sulfate. You need to know their symbols. You need to know that sodium is a metal found on the periodic table. You need also to know its valence number. You also need to know the formula for sulfate I showed you in the previous videos. So these are the radicals. Sulfate is a radical. Okay, so sulfate is a radical. So these are the radicals that I gave you here. Okay, so you need to remember all those radicals that I gave you. So we have sodium sulfate. So sodium, we write it as this. It is on the periodic table. It is like this. It has the symbol, chemical symbol of this one, Na. This is sodium, like that, and it's in group 1. I said that those elements which are in group 1, they have the valence number of 1. Okay, they have the valence number of what? Of 1. You write down the valence number like that. Then we have sulfate, right? We have sulfate. Okay, so what is the formula for sulfate? So sulfate doesn't start with letter S. Okay, sulfate doesn't start with letter S. It starts with capital letter S, not just S. It is capital letter S, capital letter O, 4, like that. Meaning that there are 4 atoms of oxygen and 1 atom of sulfide, okay, of sulfur I should say. So you need to know its valence number. I gave you these radicals. This is one of the radicals, and it is not found on the periodic table. This is how it is written. You should write it like this: capital S, capital O, then the 4 down there. So this one has a valence of 2, like that, as a valence number of 2. And then the next thing that I said is to swap their valence numbers. You swap their valence numbers, then this 2 comes here, this one comes here. Okay, the next thing to do here is to look for a common factor. A common factor is a number when you divide in these 2 numbers, it will give you 0 remainder. So it will not leave any remainder if you divide it in these numbers. Okay, so what is that number? And that number is just 1. 1 can go into 1 without leaving a remainder. 1 can go into 2 without leaving a remainder. Okay, so when we divide 1 here, 1 here, okay, so we are going still to have 2 here to have what? 1. All right, like that. So meaning that sodium is what? Is sodium like this. Then the carbonate comes like the sulfate comes like that. Sulfate 4, like that. Okay, so I said that if I said that this means that this is just multiplying this by 1. Okay, it is multiplying this by 1. All right, so I said that, note that if this the number that you have exchanged with anything, the number that you have exchanged with any metal, or it can be a radical, if it is just greater than 1, okay, if it is just greater than 1, then put this in bracket, leave it in brackets. But if it is not greater than 1, it is not bigger than 1, leave this in outside the brackets. This is just as you write it like this: sodium 2, then sulfate, like that. This means that this one has multiplied this one, as you have multiplied 1 with everything inside. Okay, so it will give you something like this. So this is what you are supposed to write as the chemical formula for sodium sulfate. The other formula that we are given is for beryllium. Okay, so beryllium, we have beryllium. Beryllium is in group 2. So the symbol for beryllium is B, like this. Okay, so beryllium oxide, they said beryllium oxide. So this is what? This is oxygen, like this. Okay, so what is the chemical formula for the symbol for, I mean the valence number of this? So here beryllium has a valence number of 2. Since it is in group 2, it is a metal, meaning that it gives 2. Even oxygen is a non-metal, it receives what? 2. Okay, so as simple as that. So when these 2 swap their valence numbers, when this 2 comes this side, this 2 comes this side, like this. Okay, let me indicate the arrow so that you'll be able to see how these are going. And when you look for a common factor, a number that you can divide in both numbers without leaving a remainder, what number is that? That number is actually the same 2. So you can divide 2 into 2 and it won't give you a remainder. So it would, you know, divide 2 over 2 here, 2 into 2, it will just give you 1. 2 into 2, it will give you 1 here. So mean that you have 1 beryllium, 1 oxygen. 1 beryllium, 1 oxygen. So mean that there is just 1 beryllium. BE 1 then O1. Okay, like that. But you don't write it like this. This is just saying that in mathematics, this is just saying that 1x, and 1x doesn't make sense. 1x like that. So we just say it's x. Okay, so same applies to this one. It just be O. So this is the symbol for beryllium, like that. So this is actually what you are supposed to write, like this. Then the next one, we have iron 3 carbonate. Iron 3 carbonate. So iron 3 carbonate, the symbol for iron, the symbol for iron. So the symbol for iron, it is just Fe. Okay, the symbol for iron is just Fe. Then carbonate, you should know that it's a radical. And how do you write carbonate? You write it capital C, okay, capital C, capital O, then 3, like that. This is how you write carbonate. So this is carbonate as a valence of what? Of 2. I sent you the radicals and their valences. As a valence number of 2, then carbon 3. If you just see carbon 3, okay, when you just see, iron 3, meaning that iron as a valence number of 3, you need to be careful on this one. These are transition metals and they are specified, they're given specific valences. So they will specify iron 3, iron 4, iron 6, iron 2, like that. So here they said iron 3, okay? So mean that it has a valence of what? Of 3, like that. As simple as that. So the next thing, you swap the valence numbers, okay, like that. The valence numbers 3, as simple as that. Okay, so the next thing is you divide both sides by a common factor, meaning a number that can go in this one and this one without leaving a remainder, and that is 1. And when you divide 1 into this, it will give you just 2, and when you divide 1 in 3, it will give you 3. So mean that there is, you write iron 3, iron 2, you divide, so it will be like this, 2, then there is 3 here. So this carbonate, okay, this 3, it is for this one, this is how you write it. So don't change anything. Don't think that this 3 you can divide. No, don't divide this 3. So it is written like this, carbonate. I just got this the way it is. It is here. Then this 3, you put it to this side, okay, and this is a radical, okay, and if the number that you've swapped to it is greater than 1, it is bigger than 1, it is starting from 2 going up, okay, starting from 2, as simple as that. So this 3, so this 3, it is here. I just got it from here, like I said, I just got the way it is from here. I had to put it here. And I said that if the number that has been transferred or exchanged, and the number which has come to a radical, if it is more than 1, meaning starting from 2 going up, you put the radical in the bracket like this. Then you put that number here, and the number is what? Is 3, like that. Is it 3, like that? So this is how you are supposed to write this iron 3. Okay, this is how you are supposed to write iron 3. And finally, lastly, we have this, we are told to write the chemical formula for calcium hydrogen carbonate. So carbonate has a valence of calcium has a valence of 2, okay. The hydrogen carbonate, Yeah, so lastly we have this other question for calcium and hydrogen carbonate. So therefore hydrogen carbonate has a valence of 1, like I said last time. Hydrogen carbonate has a valence of 1. Then calcium, it is in group 2, it has a valence of 2. Okay, so this is a symbol for calcium. It's just Ca, capital C, small letter c, like that. Then hydrogen carbonate, it is hydrogen carbonate, like that. Hydrogen carbonate, like that, as simple as that. You should know this radical. You should know this radical. You won't be given on the exam, and it won't come on the exam on the periodic table. They don't give this one. You need to know it by heart. So you need to know its valence number as well, and the valence number is actually 1. Okay, it is 1. That is its valence number. Then the valence number of calcium, since calcium it is in group 2, so its valence number is what? Is 2. Okay, so when these swap their valence numbers, the 2 comes here. Okay, then the 1 comes here, and if you look for a common factor, the number that you can divide in both numbers without leaving a remainder, what is that number? That number is actually 1. Okay, and when you divide 1 into 1, it will give you 1. When you divide 1 into 2, it will give you 2, meaning that these numbers will be just the same. So you get it like that. So meaning that calcium will be what? Will be just 1, like that, calcium. All right, then hydrogen carbonate, since this is a radical and the number that has been given to it is more than 1, it is more than 1, meaning that it's supposed to be in the bracket. As simple as that. Okay, as simple as that, like that. Okay, like that, and the 2 come here, like this. So this is how you are supposed to write it. This is how you are supposed to write it. Okay, so this is how you are supposed to answer this assignment that I gave you. So you can actually refer to this. If you didn't do this, if you are new member of the group or new member of the channel, you may kindly subscribe to my channel so that whenever I do a lesson, you might be notified anytime I do a lesson. So if you need online tuitions, this is my line, my WhatsApp line. You can WhatsApp me on this same line, or you can give me a direct call. My line is 0975334778. That is my WhatsApp line. So I was presenting this assignment to you. I was actually making it easy for you. I'm sure you've understood, and the next time we are going to meet online, we are going to do balancing of equations, since we now know how to make a chemical formula. So I'm Tutor Patrick Divine. You can call me on this line. Suppose you need tuitions or you have a question. Thank you for watching. Enjoy your day.